Hello, dear students. Welcome to lecture 1 of Mechanical Properties of Solids. In short, this chapter is also called Elasticity. This is your chapter from your second book of physics for class 11. So, before discussing anything like elasticity, like the topic elasticity, I just want you to think about what you understand by elasticity. Like, what are the things that come to your mind when we say something is elastic? So there must be something like these rubber bands which you pull and you call them elastic. So well, or maybe there are some type of straps which are tied in our pants and sometimes in some bags or something, and these material are called elastic. So we all have just various information regarding elasticity. In this chapter, we'll discuss in detail about what elasticity is and what type of material are those and where are they used. So everything related to that will be discussed in this chapter. So let's start with today's topic. Today's topic is before studying elasticity, we need to understand what is a deforming force. Deforming force, as it is mentioned, a force which can change size and shape or both of a body. That means, suppose you have something, let me show you. Suppose we have this comb here. I have this comb here. When I apply a force, you can see its shape is changing. It was first straight and now it has become a bit curvier. So we can say the force applied by me changed its shape, not size. Size has remained intact. Now suppose you take a that balloon and compress it from all the sides. So I can say that size and shape both were changed. Or maybe you can take a steel scale like this and apply a force like this. See, you can see that size may not be changing, but shape is changing. So any such force are called deforming force. Okay. Now suppose the scale is in my hand and I'm slowly lifting it up. So I am applying force on the scale. That's why the scale is going up. That means, is this force deforming force? No. Why? Because this force is not changing the size and shape of the body. So all forces are not deforming, though some forces are, depending on how they act and where they act. Okay. So we'll just for the time being, just know this part of deforming force. Later, as we go on to the chapter, we'll discuss a lot about deforming force. Next is elasticity. So this is the most important definition of this chapter, and this will lay the foundation of whatever we are going to discuss. First of all, elastic body. It is the ability. Elasticity is the ability of a body to regain its original size and shape. Once deforming force is removed. Let me give you one instance. Suppose I take this scale, that steel scale that I showed you, and I apply some sort of deforming force. This is deforming force. And I let go of deforming force. You can see the scale quickly regained its shape or size, whatever. It quickly regained its shape and size once the deforming force was removed. I'm explaining it again. First, I apply a deforming force. Once I remove the deforming force, the body is regaining its size and shape. Thus, this body is called elastic. Elastic bodies allows deformation in them, but whenever the deforming force is removed, they will regain their original shape and size. I hope this part is clear. Next is, the quicker it regains its size and shape, higher is its elasticity. Now there may be some sort of bodies. Suppose I take it and I let go of it, it will slowly come. There are some sort of plastic bodies which take some time to regain their size and shape. So these are less elastic bodies. But some bodies which quickly regain their size and shape are higher elastic bodies. Now I will show you some example of this inelastic body. Suppose this body, it does not have any elasticity. Why? I take this paper and I crumble it. So I have applied a deforming force because its size and shape is changed. Moreover, its shape has changed. Now, as soon as I let go of deforming force, suppose I'm not applying any deforming force now. Is the body, regaining its original size and shape? No. So I can say a paper is non-elastic body. I hope this part is clear. Okay. So kindly note down whatever is written in the board. The next is types of bodies. So what are the types of bodies we have? We have three types of bodies based on their elastic behavior. The first is elastic body. They fully regain their size and shape once the deforming force is removed. They fully regain. Example, I've already shown you the steel scale, and the another example is ivory. Now you must be wondering what ivory is. Have you seen? Obviously, you have seen the tusk of an elephant. The tusk of an elephant. So what it does, it carries heavy weighing logs of wood in this tusk. So whenever the logs of wood it carries, so the tusk bends a little bit. Whenever it carries the weight, it bends a little bit. But as soon as the that load is removed, it regains its shape. Though the deformation is very minimal, as compared to whatever load it is carrying. But what happens is it completely regains its shape. Hence, it is called elastic body. Understood? Now you must be wondering that what is that has to do with this? See, you must understand that an elephant carries heavy logs for the rest of his for a big part of his life, and still those bodies, they do not flatten up. These stuff, they do not flatten up. They always remain curved. Whenever they carry the load, it bends a little bit. Whenever they remove the load, it comes back to its original position. So it's very important for elephant to have an elastic tusk. Otherwise, even after taking one log, it will just straighten up, and after that, it cannot carry anymore. So let's get back to our inelastic bodies. The second body is inelastic. They are not able to regain. They are not able to regain their size and shape once the deforming force is removed. Like dough. Have you seen that atta dough, which is used for making chapatis? So what they do, they just press it, and once you press it and let it go, it will remain the same shape as it was. It simply means that it cannot regain its shape. Similar to your wax also, the candle wax, it's again inelastic. Last is partially elastic. So this is the case. This is like all the bodies present in this universe are in this region. They're somewhere between elastic and inelastic body. I'll give you one example. Like you can say this bottle, if you press it, it may not completely regain its shape back. A small part is always deformed. So everything in this universe is partially elastic, or we can say partially inelastic. So these are the three types of bodies. Kindly note them down. Let us move on to our next topic, that is stress. You, as a student, you must have heard about stress and all in your life, day-to-day life. That is the psychological stress that we are talking about. We'll talk about the mechanical stress, the stress which happens in physics. Okay, not because of physics, but in physics. Okay, so stress is the restoring force acting per unit area. Before doing this, you must understand what is the restoring force. Now, suppose I have an elastic band here. Consider it to be a rubber band. Okay, a rubber band. I have a rubber band here which is tied to a fixed ceiling. The ceiling cannot move. Okay, suppose it is tied here, and this part, this ceiling, C-E-I-L-I-N-G, ceiling cannot move. Okay, now I have applied some downward force in it, due to which it has started going down. Obviously, if I pull it in the downward direction, it will come down and it will stretch. Why will it stretch? Because this downward force is a deforming force, and this downward force is trying to increase the length. Hence, its length will increase. By how much amount? This much amount. So I have applied downward force called as F external. Applied by whom? Me. Now the body is elastic, alright? Suppose I let go of this force. What will happen? Suppose I suddenly, just let go of this band. It will quickly regain its shape and size. This is what happens in elastic bands. You take an elastic band, all the girder or whatever you wear, girls wear that generally. Some boys having pants also, they wear it. So suppose you take that and you stretch it and let go of your one hand. It will quickly try to regain its shape and size. So as soon as I let go, it will quickly reach here. Alright? That means as soon as I let go of my external force, some force applied by the molecules of this, material is trying to pull the body in the upward direction. and that force applied by the material or the molecule of the body is called restoring force. And restoring force is trying to restore the original shape and size. Understood? So as soon as I apply some sort of force in the downward direction, the restoring force keeps on acting. As soon as I let go of external force, the restoring force pulls it back to the original position. Therefore, the stress is defined as, it is represented by sigma, all right? Represented by sigma. You must be thinking, what am I talking about? These are the Greek letters which we will use, okay? This is called sigma. S-I-G-M-A. Sigma. Okay? Just take a line and rotate it by 90 degrees. It will become sigma. Okay? So it is represented by sigma. It is given as F restoring per unit area. Alright? Now, suppose I have stretched it and now this is in equilibrium. Equilibrium means it is not even going downward, it's not going upward. That means the force applied by me is equal to the force applied by the material. That means at this condition, at equilibrium condition, F external is equal to F restoring. I hope this part is clear. Now, what are the types of stress that we have? First is the normal stress. What is normal stress? Normal means perpendicular, and perpendicular means force is perpendicular to area. In this case, you can see this elastic band that we have must have some sort of cross-sectional area. Suppose that cross-sectional area is A. So we can say restoring force is in upward direction and the area is like this. So I can say force is perpendicular to area because force is acting like this. This is area and this is force. They are perpendicular to each other. I hope this part is clear. So there are two types again, tensile and compressive. This is tensile. Now suppose, kindly write this point. In this case, it is tensile. Tensile means when the length is increasing. Tensile means what? When we are pulling it, when we are pulling it. Now suppose we have another elastic body, something like a steel rod, okay? This is the same steel rod. Now instead of pulling it down, I'm pushing it upward. So if I push it upward, it will become like this. Alright? So in which direction did I apply my external force? External force is applied in this direction, and the restoring force, as soon as I let go of external force, this will come down. That means restoring force is acting in which direction? Downward direction. This is called compressive because it is trying to compress the body. So in both the cases, the restoring force is acting perpendicular to the area of cross section. The restoring force is acting perpendicular to the area of cross section. Okay. Therefore, normal stress has two types, tensile and compressive, which are explained here. This is for tensile, this is for compressive. Kindly draw respective diagrams. Next is shear stress. Now, before explaining shear stress, I would like you to draw the diagram and write everything in the board so that I can bring out some space. I hope you have written already. Anytime you can pause the video and note down. Now, before explaining shear stress, I would like to show you one example using a book. Suppose I have this book here. And suppose it is kept in my hand, and suppose this left hand is fixed. I take my right hand, I place it over the book and apply a force in that direction, like this. See, book was like this initially. Now it is moved like this. Just kindly just take some observation. Now I will explain shear stress. Once I explain the theoretical part of shear stress, I will again come back to the book. Don't worry about it. The book is going nowhere. I had this book. All right. Now I applied force in the body in this direction. Force is what? Force in the body in this direction. Obviously, the body will turn like this. Understood? The body will turn like this. How? See again. The rectangle that I have drawn here. Let me just name it. A, B, C, D. Let us call it B dash, C dash. The rectangle that I've drawn here is this rectangle, A, B, C, D. As soon as I apply the force, it becomes A, B dash, C dash, D. So I'm applying force in this direction, and force is being applied on which surface? The top surface. And you can understand this force is parallel to the area. Therefore, we can say the force is parallel to the area in case of shear stress. And this type of stress is called shear stress. I hope you understand the point. This is called shear stress. Both are represented by sigma only. Okay, kindly note them down.